Okay, so for the second part of this, we can take functions and you can graph those in Desmos, obviously, and you can see what has happened in the transformation, right? So we did absolute value, we did a quadratic. You could pick any function and type it in and graph it and see it. But it's important that you kind of understand or anticipate what kind of transformation you might get, right? So in the previous class where we looked at the different types, remember I said our toolbox of functions, so to speak. Here's our different functions, right? And you know what those look like in a basic sense. The parent function that we talked about. When you do a transformation, then you should have an idea, hey, so how is this going to affect my graph, right? So if we talk about, say, y equals x cubed, okay, and then we say, well, what if I did this? What's that going to do to my function? So, obviously, again, you can type it in, but that's not what we're looking for. So what we want to be able to do is describe what's happening. So then we would say, well, this is a vertical stretch, right, of 2. So the scale factor is 2, right? Same thing. Let me start using some function notation here. What if we had this? Then, what's that going to be? Well, we know that that is going to be a horizontal shift of 3 units and a vertical shift of 1 unit. Okay. Now, since, again, we know what these graphs look like, so we also should be able to graph this. And we know that 2, hey, that's a vertical stretch, so it's going to stretch that graph. All right, so instead of, it's going to look a little more like that, stretched out, right? Here, okay, we're going to have a shift of 3 plus 1, so we're going to shift it over 3 and add a 1. So it's going to look pretty normal, but it's going to be shifted over a little bit. Okay. So we should be able to describe them and draw these functions. Okay. What if we did this? So now we have something like this. So this is written in a little different way because it says it does it actually on the function. So here we have to kind of think, which one of these things does this represent? So for example, what does that represent? For example, what does this represent? Okay, so when we have a situation like this, okay, we have to kind of go back to this original equation here. So I can see that anything out in front of the f, well, that's my a value. So I know that this is going to be a reflection over the x-axis. And I know that this is my c value here. So I know that's going to be a slide of -1 unit horizontally. Okay, so here I know what the function is and I can change it a little bit. This is a little different notation, but it's for the same function. It's just written a little differently. All right, so those are the types of things that you should be able to do as you're doing these problems. All right, let's take it a step further. What if they give you the graph and we have no idea what that function looks like? So let's say we have something like this. I'm going to put a little wiggle in here. And then I'm going to have it go back up. kind of like a W. Okay, and I say, hey, this is g of x. All right. So now I want to perform translations on or transformations on this. So let's say that we go y equals, all right. Let's say go 2g of x plus 1. Okay. So I look at this and I say, well, I have no idea what g is, so I can't type this into decimals because I don't know what it is. All right. But I do know about transformations. I do know what that does, and I do know what that does. All right. So what does the 2 do? All right, that is a vertical stretch. So I know that I'm going to stretch this thing, and what does the 1 do? It raises it up. Okay. So the question now becomes, what is going to happen first? Am I going to raise this up and then stretch it, or am I going to stretch it and raise it up 1? Because maybe it's going to give us a different graph. We have two different things happening here. All right. We don't know what this function is, so we can't really figure it out by typing it in decimals. But here's what we do know. There's a definite order of operations to things, right? And we know in that order of operations we're going to do anything that's in the parentheses first, and then we follow it with powers and so forth, right? Okay. Same thing's going to apply here. All right. We don't have anything in the parentheses. We say, well, we have an x, but there's nothing being affected to that x. We do have a multiplication and then an addition of 1. All right. So that means that I'm going to do that vertical stretch first. Okay. So any value that I get out of here, I'm going to vertical stretch it, and then I'm going to add 1. So let's look at this. I'm going to change colors to something a little different. Let's go with this nice purple here. So as I look at this thing, I see that at about -2, this is about 4. Okay. So at -2, I have about 4. So now at -2, I'm not going to have 4 because I'm stretching it, right? Instead, I'm going to have like an 8 value. Okay. We'll say this is a 0, 0. And then we'll say, well, at about a half, it kind of crosses that x-axis again. So at a half, right, it's going to cross that x-axis again. But in the meantime, it's going to drop down. So I'm going to get a little more of a loop there. Okay. Same thing is going to happen here, right? And then it's touching again right about there. And then we have at about 1, 2, 3, 4. We have 4 again. So at 1, 2, 3, 4. We're going to double that and go up to 8. So our graph's going to kind of look like this. All right. But you say, wait a second. You never even did anything with the 1. Well, watch. So now I'm just going to raise this all up 1. All right. I'm just going to raise it all up 1. So now it looks something like this. Okay. So it's sometimes helpful to do the first part of it and then do the second part of it where you're going to raise it up 1. All right. Okay. So let's go back to this a little bit more. Say we have this as our basic function. Okay. And let's say we're going to do this. Okay, so what's going to happen first, right? Now, yes, we could put this in the decimals and graph it, but let's do this first. Okay. Let's go ahead and see if we can figure out what this transformation is going to look like. First of all, I know that this square root graph is going to look something like this. Okay. So in this situation here, what are we going to do first? What does our order of operations say? Well, hopefully it said it's going to do that first. So that means that graph's going to be shifted over 1 unit, right? Back 1 unit. So this is going to be here now. So I'm going to get that. Okay, then what would be next? Well, hopefully you said this. So now that's going to reflect over the x-axis. So it's going to look like that. Now what does a minus 2 do? That's the last thing that's going to happen. It's going to shift it down. So this is now going to be shifting down to here. Okay. So if I go into Desmos and I type that in, that's what I should get, right? So you have to kind of follow the order of operations when you're doing transformations and be relatively aware of that. I don't think there's a whole lot more to that section. There's some pretty good problems on page 99 that maybe I'll give you one of them to play with as an assignment problem here. But the rest of them are pretty much what we've been talking about. Describing the transformations, drawing the graphs. They have you do some writing things. We haven't done anything like that. Maybe we do one like that. So let's say that we have a function f of x and we want to write the transformation described. So let's say that we have a vertical stretch. Oops. Of 1/2 and a vertical shift of 3. So what would that look like? Well, we don't know what the function is, right? We just know it's called f of x. So I'm going to go y equals, I have a vertical stretch of 1/2. So that 1/2 is going to pop out in front. Okay, f of x. I have a vertical shift of 3. So that's going to be up 3. So that's what that would look like. So you're just taking the transformations and writing it in terms of the function. Let's try another one. Same thing, f of x, right? So let's go like this. Let's go reflect over y-axis. Okay. Shift horizontally. Two units. Okay, so now I have a reflection of the y-axis. Well, we haven't done anything with that. So we have to kind of look back and see, geez, what did that? Okay, what did that reflection over the y-axis? Well, hopefully you said that's when we had a negative x, right? So if we have a negative, I'm going to go x minus, I'm going to put 2 there, I'm going to close it like that. Okay, now is this different? Are these two things different? And the answer is yes, they are, because this negative and this negative, remember this was your b value, all right? If you put this like this, then the b becomes a negative, but that changes what happens with that, okay? So for example, let's look at this. So let's say that we're talking about the difference here of y equals, or f of x equals, let's stick with this guy. So let's go with x minus 2, oops, let me stick a negative out in front, versus this. Okay, graph those two and see what happens. So if I go, and I can't show you on here because I'm not at home now doing these, so I don't have access to the internet, but I'm typing this in the Desmos as I speak. Oops. Okay, so as I look at those, you can see that the different starting spots, right, with the two graphs. Okay, so they are not the same thing. So we want to make sure that we're doing this correctly. So let's see, we reflected over the y-axis, which is what we did, and it shifted horizontally 2 units. So if we shift it over 2 units, right, we're going to get a starting point of 2, and then now we're going to reflect that over the axis. So normally if we had y equals square root of x minus 2, I would get that, and then if I reflect that over the y-axis, then I get the graph that I'm looking for. All right. So here, again, this is an interesting question, because what are we doing first? Are we reflecting first, or are we shifting first? Well, in this case, right, we want to do what's in the parentheses first. So we're going to shift it over, and then we would reflect it, all right, which is going to give us okay. I want to make sure we have that clear here. So I paused this and took a look at it. So here, this first one, all right, does the shift, or excuse me, does the so the first one does the reflection here first, then the shift, because of that negative out in front of the parentheses. This one does just the reverse, does the shift, then the reflection. Okay, so if we looked at this, this one does the reflection. So the normal graph, right, looks like this. This one's going to do the reflection, and then it's going to shift it over, right? So it looks like that. Okay. This one down here, though, does the shift. So it goes like that, and then it does the reflection. So there are two different things. So you have to kind of be careful with whether the thing is on the outside of the parentheses or on the inside. Okay. It makes for an interesting problem. All right. I had to actually look at it myself a little bit because it's not real clear. We don't do a lot of things with the B's because they are harder to work with in the general transformations. When you're with if you take 112, you do some sine cosine curves, it's a lot easier to figure out what the B value does. All right. So let's see. I'm going to do another part of this where I'm going to need the internet. So I'm going to go ahead and save this one. Sorry, it's kind of choppy, but I'm going to do this when I get some internet service so I can show you some GeoGebra stuff. But this is pretty much what you're going to do in 1.5. And don't forget about your review is online. You also have a copy of it, hard copy, and you can go get it online. And I'll also post the solutions to the review, so you get that as soon as I can get those done and uploaded. All right. Okay.